So section 5.3, there really isn't a lot to talk about on the movie because we're going to do this graphing in class, but I would really appreciate it if you would do a lot of these steps before you come so we can spend the bulk of the time actually drawing graphs. So you can definitely do a lot of the steps ahead of time. So this is graphing rational function. So that's the only objective is being able to analyze the graph of a rational function. So these are the steps. Factor the numerator and denominator. So I'm going to take this example, capital G of x equals x cubed plus 1 over x squared plus 2x. And just remind you of some of these steps and what they mean. So factor the numerator and denominator. So this is what I was talking about the other day, that you have to remember how to factor sum and difference of cubes. Let's see, this is going to be x squared and x and 1. Same sign, opposite sign, always positive. Same sign, opposite sign, always positive. So you can multiply that back together again to check if you want. And that's how you factor the sum of cubes. Then in the denominator, I just have a GCF of x. So I'm going to factor that out. So I factored out numerator and denominator of r. Find the domain. Well, x times x plus 2 equals 0 when x equals 0 and x plus 2 equals 0. So that happens when x equals 0 and negative 2. So the domain is x can't equal 0 or negative 2. Okay, and then write r in lowest terms. There are no matching factors in the top and the bottom. But that step just says look and make sure that there aren't matching factors in the top and the bottom. So then we're going to find all the intercepts. So remember, x-intercepts are when is the numerator 0? Because g of x will only equal 0 when the numerator is 0, right? It doesn't matter what the denominator is, now that we have it in lowest terms. If the numerator is 0, the whole thing's going to be 0. So x cubed plus 1 equals 0 when x cubed equals negative 1, when x equals the cube root of negative 1, which is negative 1. So we have an x-intercept at negative 1, 0. And this is the only x-intercept. So remember, you're finding positive information of there is an x-intercept here. But the other thing you know now is there aren't x-intercepts anywhere else, or you would have found them at this step. Okay, then let's locate the x-intercepts and then find the behavior of the graph near the x-intercept, and we'll talk about that at the very end of the previous section. So we'll do that together. So then vertical asymptotes, those are really the same thing as the domain, because you're going to have vertical asymptote when x equals 0 and x equals negative 2, because those values would make the denominator 0, which would make the function undefined. So those are vertical asymptotes. So we're going to be drawing those. Please bring a straight edge. If you have a 6-inch ruler, that's perfect, but you can also use a credit card or any kind of straight edge, but I'm going to want you to do straight edges to do axes and asymptotes. Okay, so then we're going to look for a horizontal or oblique asymptote. Well, we're going to look at the degrees here, and that's the last bit of section 5.2 that we haven't done in class yet. But the degrees, if the degree of the numerator is 1 larger than the degree of the denominator, that's when you get those oblique asymptotes. So you take x cubed plus 0x squared plus 0x's plus 1, and you're dividing that by x squared plus 2x. So you need an x here, and then multiply, and subtract. So you're going to subtract. So you get negative 2x squared plus 0x is plus 1. Then you're going to have negative 2 and get negative 2x squared minus 4x and subtract. Subtract means add the opposite. So I get 4x plus 1. So g of x is the same function as x minus 2 plus the remainder, 4x plus 1, over the divisor. And you don't stop until the remainder is 1 degree lower than your divisor that you're dividing by. So now we can see that this part of the function, this goes to 0 as x gets really large. So g of x looks like y equals x minus 2, an oblique line as x gets large. So this is an oblique asymptote or a slanted asymptote. Okay, so we found the oblique asymptote. And we need to find if there's any points where the graph intersects that asymptote. So this is a big idea of, does it ever happen that x minus 2, y equals x minus 2, actually equals g of x? Is there an x value or a point on the graph where this is true? So that's how you find points of intersection. You set the equations of the graphs equal to each other and see, does this ever happen? So it looks like we're going to get x cubed plus 2x squared minus 2x squared minus 4x. We want to know, does that ever equal x cubed plus 1? And we get negative 4x equals 1. So it does happen when x equals negative 1/4. The graph of g of x intersects or runs into the oblique asymptote when x equals negative 1/4. And we can figure out where that point is and what the graph looks like together. So we're going to use the zeros of the numerator and denominator to divide the x-axis into intervals. So you're going to take your graph and you're going to say, let's see, I have a vertical asymptote of 0 when x is 0, so the y-axis, and one at negative 2. And then you have an x-intercept at negative 1. So each of these things subdivides the graph into pieces. So this graph is going to have 4 pieces. And then we have the oblique asymptote y equals x minus 2. So the oblique asymptote has a y-intercept of negative 2 and a slope of 1. And I'm just going to put some little dashes here so you can tell that's the oblique asymptote. So the oblique asymptote is something we're going to have to figure out what's going on with that, but it is going to help us with drawing the graph. Okay, so then we use the zeros of the numerator and the denominator to divide the x-axis into intervals, and then we need to figure out where the graph is and analyze the behavior of the graph near the asymptotes. So the number 34, if you would do all this work before you come to class, we could spend a lot more time working on the graph. So if you could find the zeros of the numerator and the denominator, find any vertical asymptotes, find a horizontal asymptote, that would really help us get a big head start on the graph. And that's all we're going to do in this section.